Very nice. Okay, we have a parallelepiped with edges disguised. So, or the parallelepiped generated by these vectors. What is this? So in R3, when you have three vectors, U, V, and W, then you can make this funny box thing out of these three vectors. You first make a parallelogram on the base using U and V, and then we'll make it a three-dimensional box. It can be a little bit tilted one, but this guy is called parallelepiped with those edges or generated by those vectors, okay, or defined by those vectors. Now, the formula we have, or the fact that we have, is this. We are interested in finding what is the volume of parallelepiped defined by UVW. So maybe I should write this in black. Okay, volume of parallelepiped defined by U, V, and W. Okay, so there is a formula for this. The whole thing is this. You take cross product of two of these vectors, U cross V, and then this will be a vector, yes? You can dot product this vector to the third vector. When you dot product, you get a number. That number can be positive or negative. Volume is supposed to be always positive, okay? So that's why we put absolute value of that. While here, you may see different orders of this thing. For example, you may see this thing, V dot U cross V, W dot U cross V. That is the same vector, the same number. You may actually choose any two vectors of these guys, first cross product, and then cross product with the third one. There is no U, V, W given like, okay, this is U, this is V. There is, the formula works this way. So cross product of two vectors, so cross product of two vectors. This is a vector, and then dot product it with the third vector. And then that is a number, find absolute value of it. Okay, so in this specific case, we have a U, which is 0, 0, 2. Vector V is 1, 0, 1. And vector W is 1, negative 7, and 0. So we have to start with cross product of these two vectors. Again, it doesn't matter which two you choose. I will go with the formula that you have there. So we are cross producting 0, 0, 2 and 1, 0, 1. So 0, 0, 2, 1, 0, 1. The first one will be determinant of 0, 2, 0, 1. Yeah? Let copy, okay, yes. Okay. The second one would be negative determinant of 0, 2, 1, 1. And the third one will be determinant of 0, 0, 1, 0. Okay, so now, this is 0 times 1 minus 0 times 2, negative. 0 times 1 minus 2 times 1, and 0 times 0 minus 0 times 1. So the first vector, the first component is 0. The second component is 0 minus 2, which is negative 2, times another negative sign, that is 2. And the third component is 0. Now, u cross v, which is a vector, you can dot product to the third vector w. So 0, 2, 0, dot product to 1, negative 7, 0. Let me just check that one again. Yes. And dot product is you multiply the corresponding components and then add them. This will be a number. In this case, it is negative 14. Negative 14 is not volume. Volume must be always positive. The volume is absolute value of u cross v dot w, which will be absolute value of negative 14. Absolute value means that if it is negative, just drop it. So it will be, drop the negative side, it will be 14. So that means that, okay, yes. You see, before you even start, you can obviously see that B and E cannot be negative. Length, volume, and area cannot be negative numbers. So you should never get a negative number. So that is what you have here for this question. Okay? Any question, any comments here?
I have a question.
Sure.
I just wanted to confirm that U, V, and W are all interchangeable, because sometimes it doesn't tell you which vector.
Yes, that was what I was trying to say at the beginning. When you see it this way, you see cross product of two of the vectors dot with the third one. It means that there is no like UV important thing as UV. Just these are three vectors. Take two of them, find the cross product, and then dot product with the third one.
Why can't it be negative?
Oh, volume is not negative. Volume is like, okay, volume of this object here is always positive. Like how much water this box can contain. It's always positive. Area is always positive. Length is always positive. Does that make sense?
Yeah, thank you.
Okay, welcome. And yes, in this formula, after you do the computation, the absolute value is an important thing that you have to apply, but obviously you can see if you're making a mistake there. Okay. Let me move to the question 7.